Good morning, students. Very good morning to all of you. In earlier class, we discussed about the stability analysis belongs to the electric drives. So the electric drives are rotational systems. So the stability analysis is very, very important. And this stability analysis performed with help of the steady state stability and transient stability. So generally steady state stability is enough. So in certain cases, steady state stability does not give the proper information. Then we can go for the transient stability. Yes. So in today's class, we are going to be discuss the introduction to electric drives. So I'm sharing the video here. Yes. So this is our topic today, introduction to thyristor controlled drives. Yes. So drives already you know. The drive is a motion control of any device is called it as a drive. So that motion is to be controlled with help of a thyristors. So that is nothing but thyristor controlled drives. So for making the single phase converters, three phase converters, and choppers, we need a switches. Those switches are to be aligned with help of the thyristors. Yes. So let us see how the details belongs to the electric drives are going to be discussed, and what is the block diagram of an electrical drive, and what are the various parts of the drive, and we can describe the function of each and every part here. So let us proceed here. Generally, the importance of the motion control in a present day-to-day life is, so in household purpose or industrial purpose, there is huge applications even in transportation systems also, huge requirement of motion control. Otherwise, it may cause to a dangerous operation. Motion control is required in large number of industrial and domestic applications like transportation systems. Yes, transportation systems, the motion control is very, very essential. So we are observing the number of accidents in the papers daily. So you are unable to control the motion, resulting they may hit some objective in front of them, whatever it may be. Yes. So transportation systems very, very important, the motion control. And similarly, rolling mills, paper mills or machines, yes, textile mills, machine tools, fans, pumps, robots, washing machines. So all these are the very, very essential requirements in our day-to-day life to control the motion of a device. Yes. So similarly, let us define what is the drive and what is the electrical drive. So generally, the systems employed for motion control are called the drives, and the drives employed is the electrical supply is known as the electrical drives in general. Yes. So here also the same thing is to be mentioned. Systems employed for motion control are called drives and may employ any of the prime movers for supplying mechanical energy for motion control. Yes. So here simply, what is the drive and what is the electrical drive? The motion control of any system is known as the drive, and the drive employing the electric motor is known as the electrical drives. Yes. So see the basic black diagram of an electrical drive here. So this one is the black diagram of an electrical drive. You see here. Yes. This one. So every drive has its own source, own converter, own motor, and own load. And similarly, if it is controlled in the controlled manner, closed loop is very, very essential. So you see here, the block diagram of an electrical drive represents a source block, a power modulator block, a motor, a load, a sensing unit, a control unit. Control unit is to be commanded by the input command. Okay, this is the generalized the block organization of the electric drive. Yes. So even fan you are taking, fan is also running through the supply. And fan motor is connected to a load of 3 wings. Yes, so those are rotating with some inclination so that the air is come down. Okay, so every drive you are taking, the drive may be consisting of one source, one converter, one motor, and one load. Yes, so this is the open loop system. Whenever the closed loop control is required, we can use a sensing unit as well as the control unit for controlling the motor as well as the load. Yes, so let us describe the each and every function here. What is what? Yes. If you see here, load. Generally, load is a predefined task for any operations. For example, a motor is there, which is pump the water. Yes, so the motor is as usually takes the input supply as a electrical supply and gives the mechanical energy through the shaft. Yes, so the shaft is coupled to a pump set, so that along with the motor shaft, the pump set is also running and pump the water from downwards to upwards, otherwise from wells to bore wells to the upwards, like that. Yes, so for pumping the water, the pump set is designed. For ventilating the fan is designed with 3 wings with some inclination. Is it or not? So anything you are taking, the load is a predefined one. So our motor is rotating, along with our motor, the load is also running. Yes? So load is usually a machine designed to accomplish a given task. Yes? So load is basically a predefined. So whatever may be the task assigned to that motor, the motor is to be performed. So that is the reason load is a predefined task. Yes? So example, fans, pumps, trains, drills, robots, tools, in all these cases. Yes? So all these cases, the loads are predefined one. Yes? So usually load requirements can be specified in terms of speed and torque characteristics. Usually, load requirements can be specified in terms of speed and torque characteristics as well as their demands or requirements. Okay, so that is the reason we are not giving any much importance for the load, because load is a predefined task. It is already designed, and our electric motor is to be going to run this particular load. Yes. So another important component in the block diagram. Is another important component in the block diagram is power modulator. What is the power modulator? Mainly, what functions it performs. Yes, so all these are important for us. So generally, power modulator majorly performs the following functions. So let us see what are the following functions. Is the function 1, which is the modulates flow of power from source to the motor in such a manner that the motor is imparted speed torque characteristics required by the load. Yes, so whatever may be the speed torque characteristics which are required for the motor, that should be produced by the power modulator just by modulating power from source to the motor. So this is the function 1 of a power modulator. And another one is during the transient operations. As usually, as you know, we discussed already, the transients are dynamics which are arised in the drives during the starting of the motor, breaking of the motor, as well as the speed reversal of the motor. In all these cases, so the power modulator restricts the source and keeps the current within the reasonable or permissible values. Yes? So that means that it can be act as a power modulator. Even the supply voltages are changes during the starting, breaking, and speed reversal. The power modulator does not allow, because of the alpha is to be fixed. Power modulator is controlled by controlling circuit. So that controlling circuit does not change even the voltage has to be changed in the source side during the starting, breaking, and speed reversal. So therefore, the power modulator here is to be considered as a protective device for the drive operation. And similarly, converts electrical energy of the source in the form suitable to the motor. Is, for example, motor is a induction motor, supply is a DC. So what can you do? We need to have a inverter to convert DC supply into AC supply so that the induction motor is to be capable to operate. Therefore, power modulator, what it does, it converts the source to required form to the motor. Yes, so converts electrical energy of the source in the form suitable to the motor. Is it or not? So whatever may be the manner, it may be AC motor or DC motor, the supply is either it may be AC or DC. We can use a converter instead of a power modulator. According to our requirement, the power modulator is converting the required form to the motor. Example, if the source is DC and an induction motor is to be employed, yes, so what type of converter which is required for us is, what type of power modulator which is required for us is an inverter. Yes, so inverter converts a DC supply into AC supply. And similarly, the last function selects the mode of operation of the motor, that is motoring or braking operation. So it means that the motor which is to be controlled by a converters, a fully controlled converters. So based upon the firing angle, the average output voltage may be positive or negative. So the alpha is varied from 0 to 90 degrees. The average output voltage is positive. And beyond the 90, the average output voltage may be negative. That means that up to 90, it will produce a positive torque and supports the motion. After 90, it will produce a negative torque which will oppose the motion. So these are the main purpose or main functions of a power modulator. One is modulate the power to the motor according to the required speed torque characteristics of a load. And similarly, during dynamic or transient conditions, it protects the drive under all conditions and keep the motor current within the permissible values. And similarly, converts electrical energy of the source in the form suitable to the motor. Is it or not? Okay. So, and also selects the mode of operation, that is either motoring operation or braking operation. Okay. And in all these functions, the third function is very, very important. What is this? Converts electrical energy of the source in the form suitable to the motor. This is more important for us. So therefore, here instead of this by, there are a power electronic subject which is come into picture. So what type of converters which are available for us is rectifiers, inverters, AC voltage controllers, DC choppers, cycloconverters. So these 5 types of converters are initiated instead of the power modulator, so that whatever may be the form of source is to be required for the motor is easily converting because of the control circuit. Yes. So therefore, out of all these 4 functions, the function 3 is to be treated as a main function. Here, all the power electronic converters are working to convert the electrical energy of the source suitable to the motor. So this is about the power modulator. Yes. Next one, sources. Yes. So already we know more familiarly, and throughout India. Yes. So throughout India, the frequency level is 50 Hz, and wherever you go, the single phase supply and 3-phase supply is readily available throughout India or most of the locations. So therefore, sources are generally a single phase and 3-phase 50 Hz supplies. Yes. So the drives has a low rating, for example, otherwise low power ratings. Generally, single phase source is to be implemented, and remaining when the drives are power drives, the 3-phase source is to be used. Yes. So except traction drives where high power single phase supply is used because of economy. So you can observe here, in case of the traction or railway system, only one cable is going on the top of the train, as throughout the track electrification. Yes. So it is a single phase supply, single phase 50 Hz, 25 kVA supply. What is the rating of the supply? 25 kVA. Yes. So it's a very huge powerful supply, but even they are maintaining the single phase because of the economy of the carrying three-phase is too much hard. Yes, that is the reason they are implementing only single-phase system. Yes, so most of the drives are powered from the AC source, either directly through a converter link. Yes, so when fed directly from 50H supply, the maximum speed is 3000 R. For higher speeds, the conversion of higher frequency supply become mandatory. Yes, so most of the drives, as per my perception, the speed of the drives does not exceed more than 3000 RPM. Yes, so that is the reason when high speeds are required, we have to enhance the frequency till the frequency converters. Yes, so hardly 4 poles are used. 1500 RPM is the maximum speed. 2 poles are used. 3000 RPM is the maximum speed. So if you require more than 3000 RPM, you can't do anything. You simply use the frequency converter and changing the frequency so that the speed is directly proportional to ns is equal to 120 f by p. Yes, so f is directly proportional to the speed, so that is the reason frequency has to be enhanced, the speed is also increased. Yes, so some of the DC drives is DC supplies. So we know in the throughout India there is no possibility to distribute the DC supply. So wherever DC is required in the sense, in our houses particularly for charging the laptops, charging the mobiles, whatever maybe the electronic gadgets, like nowadays television is also operating with an adapter. Yes, so for reducing the power consumption, all the devices are functioning through the DC supply. Yes, so DC supply wherever it is required, the simple adapters are used. The adapter is a rectifier where it converts AC into DC supply. Okay, so some drives are powered from a battery. Depending on size, battery voltage may be a typical value of 6 volts, 12 volts, 24 volts, 48 volts, and 110 volts DC may be preferable. In laboratory purpose, 220 volts is then obviously used in our electrical laboratories. Beyond that, for charging the mobiles, it may be hardly 0 to 5 or 6 volts. Yes, so batteries 12 volts, and the high rating batteries 24 volts, 48 volts. Yes, 110 volts. But for educational institution and research purpose, 220 volts DC is required. When DC is required, what can you do? We simply converting AC supply into DC supply with help of a rectifier. So this is about the source. So finally, what we concluded in the sense, throughout India, the frequency is 50Hz, and single phase system as well as three-phase system is readily available in most of the locations in India. So based upon the drive capacity, the drive is a low power rating or high power rating, you can use the either single phase supply or three-phase supply. So if the speeds required more than 3000 RPM, there is no doubt in that. You can use a frequency converter to enhance the frequency so that high speeds are getting. And DC is also required. DC does not transferring from substation to houses. Yes, so it is wherever it is required. Simply you can keep a rectifier and converting the AC supply into DC supply of required level. Yes, so adapters are pre-designed to converting a AC to a single phase supply into either 12 volts or to 6 volts, 12 volts or 24 volts, 48 volts or 110 volts. Is it or not? So this is about the sources which are available in the India, and these supplies are used for the drive applications. Next, you can see here motors. Motors is also very, very important. So as per the discussion of the subject, as per the syllabus of the subject, we concluded that this subject has a 5 units. Out of 5 units, the first 3 units belongs to DC and the second 2 units belongs to AC. So therefore, most familiarly, what are the DC motors used and what are the AC motors used? These are the details we are going to be discussed here. Yes. So DC motors generally classified according to the excitation. So there are 2 types of DC motors: separately excited motors as well as the self-excited motors. So separately excited motor is a separate configuration where armature and field are different. and field is externally supplied with the help of the external supply. Yes. So self-excited motors are shunt motor, series motor, compound motor, and permanent magnet. So compound motor is a combination of shunt and series, and shunt motor is almost having a similar characteristics with the separately excited motor. So resulting only two major drives are finalized for the any application according to the torque requirement. So in this regards, one is the separately excited motor, another one is the series motor. Beyond that, we can't go for the any series motor drives, because so these are to be categorized as a main motors for torque requirement. A moderate torque is required. Separately excited motor is to be preferable. High starting torques are required. The series motors are to be preferable. Yes. So similarly, whereas you come for the AC motors, so AC motor generally the most available motors is, so in most of the cases, in almost all the applications, we will proceed for the induction motors. Why? Because induction motors are readily available in the market with different ratings. 0.5 HP or 0.5 kilowatts is available, half HP is available, 1 HP is available, 1.5 HP is available, 2 HP is available. So whatever may be the ratings which is required for any application, the induction motors are readily available in the market. Yes. So there are two types of induction motors. One is the squirrel cage induction motor. Another one is slip spring or wound rotor induction motor. Yes. So another one is synchronous motor. So synchronous motor is also AC motor, but it is rotating only with one speed. That speed is known as the synchronous speed. But induction motors are available in the market with even 1,000, 1,500, 2,000 like that. But synchronous motor is very costly. Instead of induction motors, why you go for the synchronous motors in the sense, when some sort of applications, some applications where high efficiency is required, in such type of cases, synchronous motors are to be preferred compared to that of the induction motors. Yes. So wound field, that means that is the cylindrical rotor, permanent magnet, and salient pole rotors and non-salient pole rotors. Yes. So salient pole and non-salient pole. So here, salient pole is nothing but the poles are projected outside, and cylindrical rotor is nothing but it is in the circular shape. Here, wound field is nothing but a cylindrical, permanent magnet is nothing but a non-salient. Yes. So in addition to this, brushless DC motors, stepper motors, switch reluctance motors, so these also used for the various applications in the drive system. Yes. So brushless DC motors, this is the very important motor which is used in the petrol stations. Is it or not? Stepper motors, so where the steps are required, the rotation is required in terms of the stepper motors. So stepper motors are switched like the SRM. This is also very, very important. Nowadays, the research is going on through the switch reluctance motors. Yes. So in past, already we discussed about this in classroom. In past, induction and synchronous motors were employed mainly for constant speed drives, whereas for variable speed drives, DC system or DC motors are to be preferable. But nowadays, the power electronic technology is drastically developed, and avoiding the DC motors because of those drawbacks. And nowadays, slowly the AC motors are implemented to the variable drives because of the semi-converters are consisting of thyristors, IGBTs, and GTOs. Those are developed drastically in the market, so that the AC, fixed AC, is also changed into variable AC according to our requirement. Yes. So there is a final conclusion. DC motors are thoroughly available. AC motors are thoroughly available. And in past, AC motors are used as a constant speed drives and DC motors used as a variable speed drive. But nowadays, the tendency has to be changed because of the power electronics switches are developed drastically, and those are available in the market. So that AC, fixed AC, is to be converted into variable AC. It's a very simple process. So that is the reason in almost all the cases, the DC motors are replaced by AC motors. Okay. So this is about the motors. Yes. Next, control unit. Yes. So this actually in the parts of the parts of the electrical drive: source, power modulator, motor, load, control unit, and sensing. So power modulator is a converter. Power modulator is a converter either of a rectifier, inverter, AC voltage controller, or chopper, or cycloconverter. So all these five types of converters definitely works through a control circuit. Suppose it is a converter or rectifier. The turn-on methods of this SCR is turn-on methods of the SCR. How the SCRs are to be turned on? By turn-on methods: gate dv by dt triggering, forward voltage triggering, gate triggering, is temperature triggering, light triggering. But out of all these methods, gate trigger is very well-defined method because the power losses are very low. The 10 volts of pulse is enough to turn on the thyristor in the gate triggering. Yes. So for operating the power modulator consistently and accurately, the control circuit is very, very essential. Yes. So when the power modulator is a rectifier, the control unit should be a firing circuit, no doubt in this. Yes. So controls for the power modulator is provided through control unit. Yes. Controls for the power modulator is provided through control unit. The nature of control unit depends upon power modulator that is used. Yes. So it is used as a rectifier. Power modulator is used as a rectifier. Control unit is a firing circuit. Power modulator used as a inverter. Control circuit may be a PWM technique. Yes. So like this, it is a chopper, another control strategy. Yes. So it is a cycloconverter, another control strategy in control unit, like that. So the control unit depends upon the power modulator that is used. Yes. So when semiconductor converters are used, you see here, when the power modulator is a semiconductor converter, that may be a rectifier or whatever it may be, the control unit will obviously consisting of a firing circuit, no doubt in this. Yes. So which employ linear and digital integrated circuits and transistors and a microprocessors when sophisticated control is required. Yes. So generally the firing circuit consisting of, while doing the power electronics lab in this semester, you can observe that. So generally the firing circuits consisting of a linear and digital integrated circuits and transistors. And more sophisticated control is required, we can go for the microprocessors. Yes. Yes. So the major function of control unit will provide sequencing and interlocking. Sequencing and interlocking. That means that a single base fully controlled